GM everyone, welcome to today's class of the Ethereum Node Operation Bootcamp. And today we have guests here with us, Amanga, and going to be taking us on the advantages and opportunities of being a Gnosis Chain. Just going to do an introduction of Gnosis Chain and what the advantages and how you can go about becoming a Gnosis validator, right? So, Amanga, you have the floor.
Okay, share my screen. Yep. You guys, can you see my screen?
Yes.
Perfect then. Okay, yeah, my name is Arman. I'm from Gnosis core team. I'm doing a validator relation manager at the Gnosis Chain. Basically, my main role keep the Gnosis Chain network as much secure and diverse, which is including adding more solo stakers, adding more different, adding more node operators who are living in different geographies, such as Africa, such as Southeast Asia, such as Latin America. Today I'm gonna tell you about what is the Gnosis Chain and what is the main benefits and advantages of being a validator on Gnosis Chain. Let's get started. Basically my presentation is very straightforward and very basic. I will tell you about the Gnosis Chain, and then I will tell you about the fundamentals of staking on Gnosis Chain and what does it mean. So yeah, quick summary. Gnosis Chain. What is Gnosis Chain? Is the same as Ethereum. We have a beacon chain. We have a same clients. We on the execution layer side right now. We have a Nethermind and Aragon, but very early next week, we will announce two new execution layer clients. I'm sure you are guessing what is that one, like a Gas and the Red. We will be at both two clients on the execution layer side. On the consensus layer side, similar like the Ethereum, we have a Lighthouse, Teku, Lodestar, and Nimbus. We go through the same hard fork timeline with the Ethereum, but sometimes we are focusing on the how we can do in advance. And I added here that we have also focuses on the decentralization, and the main priority is the having a diverse and geographically distributed network. What is the different from the Ethereum? We were the proof of authority, but we merged 2 years ago, and we are now is a proof of stake. We uses GNO token for a staking and for the governance, and we have 5 seconds block times and 16 slots per epoch, which means that 2.4 times faster block times than Ethereum, and a third 4.6 times faster finality. So it gives lots of different use case and the different products to that building on the Gnosis Chain. As I mentioned, we have the same hard fork timeline. We passed firstly we launched the beacon chain 2 years ago, 3 years ago. I'm not sure how many years left. So we passed the merge, and the merge means is that as I mentioned before, is that we were the proof of authority, and after that, after the beacon chain launch, we changed our consensus mechanism, which is called the proof of stake, and then we passed the Chapella hard fork, we passed the Dankun hard fork, and we are going through Hector hard fork, and then we will have a Fusaka hard fork for probably next year, maybe late this year or the next year. So all of this, what does it mean for the staking side, and how we can become a validator or a node operator on the Gnosis chain? So we have two type validators. This is kind of a similar to Ethereum, and on the execution and the beacon node, which means that you don't need any kind of a token or any GNO. You can just have a hardware and start a execution layer client, and then you can follow and you can track all the chain. That means that you can run your own node for RPC, for fallback node, or for any kind of a debugging node, or I don't know. You can imagine that for the tracking the whole chain, similar like today's lots of RPC provider or RPC blockchain explorers that are using a similar technique to following all chains and building a product. So with this way, you can contribute to security of the Gnosis. You can access the network with a different way, and you don't need any trust third-party servers such as RPC ones or any kind of a wallet ones. For example, if the all RPC is down, what should I do? You should have a RPC to access the network. So it is giving a huge benefit for everyday, not everyday users, but everyday blockchain users. So yeah, you can run your validator after the post merge. So being a validator node, what does it mean? Basically, you will stake a GNO and propose and validate a block on the blockchain and earn staking rewards and the transaction fee. So all of this, be kind of you need to put some money, which is just a one GNO. Today is around 120 US dollar or 100 euro. So you can stake it on your computer, and you can start a proposal block, basically, and then you can earn rewards. So on the software side, you need a validator client, which is a consensus client, or browser-based crypto wallet to inject your GNO. It's one GNO. For the hardware side, a new machine always preferred that never have been connected to the internet, that you can use to securely generate your mnemonic phrase and keep it. But this is not a necessarily. You can use your old and rusty computer if you have your requirements is okay. So basically, all of these requirements. Just you need the one GNO for the mainnet, or you just only need a one GNO for the testnet, which is called the Chiado. It's kind of a similar setup with the Ethereum. Like right now, Ethereum mainnet has a different type of testnets, and we have also the testnets, which is a Chiado. So yeah, if you talk about the requirements, as I mentioned, is that you need just a one GNO for the minimum stake. You don't need the 32 ETH or any kind of a huge amount of money, or you don't need I don't know, lots of different type of L1s has lots of requirements. If you want to start the validator or start the run a node, so we have just a one GNO for the. I mean, this low barrier is giving a huge opportunity for us to having a bunch of different type of people can easily run a node on their home or their basement or whatever you want to run a node. I met the one guy from the Argentina. He's running a node at his old truck garage. So it's completely possible, and your imagination, I'm sure you can find some good place to start this initiative. So one GNO. After that, you need, of course, the hardware requirements, a GPU with at least 4 threads, and also you need a 60 gig RAM, the minimum one. I would say on the storage side, yeah, storage NVMe SSD preferred, of course. but it's not necessarily. You can also use the SATA SSD, but it is like it gives you a different performance. So my preference NVMe. Yeah, for the hardware side, you can also use the small ARM machine for the very without any performance expectation. You can also use the mini computer. The proper one is, I would say, is a depth node and NUC. If you have a depth node or any NUC, you will get a really proper performance. So on the bandwidth side, at least you need the 30 megabits, the average one. But if you have more than 30 megabits, yeah, this is great. It consumes around 2 or 3 terabytes per month in your monthly internet consume. So yeah, you can think about it, the whole requirements when you start a node. Yeah, on the client side, as I mentioned before the presentation, we have two type of layers. One is the execution layer, and the other one is the consensus layer. We have Eragon and Nethermind. Eragon is an archive node, and the Nethermind is one of the great execution node in the Ethereum and both Gnosis Chain. Previously, we added Get as an execution layer client, and today we have a Red as a execution layer client, but we don't have any Docker Compose image right now, but we will add it as soon as possible, and we will announce it on the next week. So on the consensus layer side, we have a Lodestar, which one is one of the minority client on the Gnosis chain. Nimbus is one of the most RAM efficient consensus layer client. If you want to use Nimbus, I highly recommend. And on the performance side, if you want to get some performance, or if you want to build some professional staking initiative, I will recommend, of course, Lighthouse and Teku. They are one of the great consensus layer clients. Yeah, on all of this, as you can see, we are supporting same as Ethereum. We have a bunch of clients, and we have a really nice client diversity. It gives us a really robust and resilient network that you can easily use any kind of a client on the chain. What is your task? What is your duty, basically? Okay, you have a hardware, you have a 1GNO, and you decided that, all right, let's start a node on the Gnosis chain. I want to be a validator on Gnosis chain. So what is your duty? Your basic and one of the most important duty is you have to build a block if you want to be a validator. When you build a block, you will get around 9 or 10% APR. So you will be rewarded. On the consensus layer side, your rewards come from the attestation rewards, sync committee rewards, and the block proposal rewards. So this kind of is similar to Ethereum. So, but also we have a execution layer rewards, which come from the transaction fee rewards. So you will be rewarded from the execution layer as a transaction fee. So this is kind of really interesting, because when we see if our chain get high performance and we get high interest, every validator we will be rewarded more execution layer rewards, which is a X-day. So one of the great opportunities, I would say, on the Gnosis chain side, we have a really solid and really strategic vision, which is called the Gnosis 3.0. Gnosis is a technology service provider for the open internet. We are building a bunch of different products. Gnosis chain is hosting these products with a very resilient and robust way. So one of these products, for example, we have a Gnosis chain on the base layer. We are building a payment specific consumer product, which is called the Gnosis Pay, is like a similar Visa card on blockchain. We are building a Metri wallet. We are building Circles is a new type of money. All of these products is top of the Gnosis chain. So we have to be secure, and we have to give the old products really robust network. So consumer focused payment oriented products, which means that we are growing and we are going through the real world use case of the blockchain. So when you become a validator, you will secure the payment network and then you will earn rewards. For example, in the real use case, I have a Gnosis Pay card. I'm spending my money through Gnosis Pay card. All of the transaction will happen on the Gnosis chain. If I be a validator, I can secure my transaction, my daily spend transaction with my validator. I mean, this is a really utopic use case, but it is happening right now. So I would say this is a great example, because when you spend the money in your bank card or in your Visa card or whatever you say, you don't know what's going on under the hood. But right now you can track all your transaction, all your money flow in your node. Of course, this is creating some sort of a big question. What is the privacy? Why everyone can see my spending history? Of course, we are also building a really nice privacy-focused products, which is a Gnosis VPN. So all of this is happening on the Gnosis chain, and every validator is supporting these initiatives as a validator, as a node. So also we have a liquid staking options, which is called the Stakewise. You can start your own vault on Stakewise. Stakewise is giving a nice opportunity for everyone. You can start your own vault and on the Gnosis chain. What does that mean for own vault? Basically, it is your own business. When you start your node, for example, you have a hardware and you are at home. You decided that, okay, I will start my node at the Stakewise. So you can promote your node, you can promote your vault in the internet, and people can easily delegate their GNO token in your vault. So you will earn some rewards from the consensus. Also, you will earn some rewards from the Stakewise. This is basically people thinking about, okay, why I am becoming a validator and what is my benefits. There is a different type of benefits, but you can also start your own business with our applications, which is called the Stakewise. Stakewise team is great, and they are also securing our network with running a node. I would say my presentation is over, and it's basically, I'm sure that in this community people know that what is the Ethereum, what is the node, and we are very similar with the Ethereum, and we have the main differences. We have a really low financial barrier. You can start you can jump into the chain with a very easy way. I'm sure on the Ethereum side it's really high. 32 ETH is it's painful for everyone, like everyday people. But on the Gnosis chain side, you don't need that. So you can easily start it. And also, I'm sure we have a few node operators at Africa, and happy to boost, happy to help for the new validators if you have any questions or any kind of requesting anything. Last year we ran a campaign with the Circles and the Aya team, and we gave a DApp node. And right now, as far as we track right now, we have around 10 node operators in Africa or the whole continent. But if we have more than 10, that will be awesome.
Thank you very much, Aman. Does anybody have a question? Please, Aman, we'd also love to have these slides just drop it in there. So,
Yeah, I mean, if anyone have a question or any kind of things, please drop your wallet address. I'm happy to give you one test GNO on the Chiado. You can try it. You can test it. Please, if you consider, please share your address on the chat.
yeah. David is saying in the comment section, NodeBridge is running 7 validator on mainnet.
Yeah, this is great. This is great.
So we're killing it, guys. Right? So killing it. Don't worry. Node by node. Very soon it's gonna be 700. So
yeah, thank you.
Yeah,
Perfect.
sure. Yeah, thank you very much, Aman. We really appreciate you for showing up for our session. People are dropping the wallet address already.
Yeah.
For the test, So
thank you so much.
I might just get it. So thank you very much, Aman, for showing up. Really appreciate it.
I would like to give my Telegram address over here. If anyone has a question, I can answer it. Yeah, this is my Telegram address. You can reach out me. Okay. Yeah, let me save this address right now on my note, and then I will send you. And Harrison and John. Yeah, thank you guys. It's great pleasure to meet you. And wish you have a great day.
Yeah. Great day. So thank you very much, Aman.
See you. Bye.
Okay, guys. That was our session with Aman, our guest speaker for the day. So much opportunity in the free space. It's also on channel, right? You can just always go to the ask the question. Or you can even ask the question on the channel so that other people can also learn from you. Harrison, are you ready for us today? Can you hear me? Harrison?
Yeah, yes, I am.
Okay. Yeah, you can take over now.
GM, guys. Hope you can all hear me. All right. So yeah, today we'll be talking about DVT and then also Ethereum staking. So we're going to be like a little bit fast because we're trying to like cover up for what we are supposed to do like last on Wednesday and to do. So it's more like combining two sessions together, but yeah, definitely still be interesting and insightful. So yeah, DVT basically DVT is just distributed validator technology. It's basically a tool or a technology that addresses centralization and security concerns around running a validator node. So we are going to explore what it is and the benefits of using it. Also, briefly on how to like set it up. So DVT basically, so it's more like a protocol that enables multiple validators to collaborate as a single validator. So instead of placing all your trust or responsibilities on one node to manage a validator's private key, DVT helps you to split the private key into multiple shares and distribute it across several nodes or several validators within a cluster. So with this approach, it helps your node to work. It helps those nodes in a cluster to work together, in validating transactions, and also it helps the protocol determine like the minimum number of key shares required to sign a transaction. Basically, there's a threshold for every. So there's a formula that just helps to determine the threshold. Let's say for a cluster of 5, the formula could be structured in such a way that you need to have 4 out of 5 validator node active and running. Anything below that, then your node or your setup might suffer, um, might face some issues. So it it helps, in splitting your private key. It helps in security wise, in the sense that um, no single node within the cluster possesses the entire key. So just like multi-sig, so even if a particular node is compromised, you'd have to um, even if a particular node is compromised, it will be very difficult to attack the the entire setup, because if one node is down, you still have other nodes that are still running the process. So in terms of consensus, um, it tends to allow multiple parties to collaborate in managing the validators signing process. So this helps to reduce centralization risk and enhance the network resilience. So basically, DVT just serves as a bridge, to decentralize Ethereum staking. Um, and this setup is something anybody can, it's something you can incorporate into your validator set, into your validator architecture. What you just need to do is, for the validator client, you then need to that's instead of using the normal validators client, you then need to set up that protocol that helps you to split the entire process. So yeah, this will become clearer as we go on. So the key capabilities of DVTs are: one, high availability without slashing. In in a vanilla setup, in a normal way of running your validator node, you just need a consensus client, the execution client, and validator client. And the validator client you're installing on your machine has just one private key. So that's the private key that tends to participate in consensus, validate transaction, and perform other validators duty. So, but if you're running a DVT, even if that particular validator is down, you still have other validator setups, other validators running in your cluster that will still perform those validators duty based on the minimum allowable number of validators for that cluster. So there's a threshold. More yeah, basically. So, and the second part is that the private key, um so there's the private key distribution and the security part of it, where your validator or validators basically use a DKG. So in OBOL, it's called it's basically you generating the uh the keys, right? So for OBOL, they call it DKG ceremony. So this is where you generate the key shares. So during this process, all the nodes in the cluster has to be active online, so that the ceremony will take place. So um this ensures that the private key is never fully assembled in one place, and it significantly reduces the risk of key compromise, as more than two-thirds of the key shares must be um, stolen for a full private key to be derived. So just like multi-sig, you just need certain number of signers or certain number of participants for um, for you to derive the full private key. So basically, how it works is there's a private key, and that private key will be splitted into uh, key shares based on the number of participants. So if certain threshold is reached, it will then derive that private key and then being able to sign that transaction. So if the threshold is maybe 4/5 or 7/10, so you just need um, seven people to sign that transaction for it to be considered a valid transaction. So for it to go through. So it's still the same approach. It's still the same approach for DVT. So also, yeah, still on the um issue of nodes or certain number, still on the threshold, um still on that threshold, right? There's still this tolerance that is expected. So, and that's where the Byzantine fault tolerance comes in. So for OBO, the mid Charion is like the middle layer. It's more like the setup that then participates in the actual validation. So it's more like it's just a middle layer, right? So just see it as that. So it's a middle layer that sits. Okay, so the Charion client in a DV cluster achieves consensus to behave like a unified validator. So what this means is that it's a middle layer that then act as your validator. So this is like the layer that helps to participate in that helps to perform validator's duty. So as long as a super majority of the nodes are honest, as long as they follow the protocol, as long as they act the way they are supposed to act, the system can tolerate Byzantine faults. So what this means is even if one node goes down, since it's still within that threshold, your validator setup will still be running as though no node is down. So until you have it up again. But if it's for the vanilla setup, if your if your validator node is down, you'll definitely be slashed. You just face the consequence, right? So you'll be slashed basically. So because you're not performing your validator's duty. So in terms of client diversity for OBO, so the OBO DVT has, like, the way it is structured, in terms of the architecture, your node, that's each node in a DV cluster can use different combinations of execution client, consensus client, and validators client. So this diversity ensures that your validator is not impacted if a specific client encounters any issue. So in terms of client diversity, overall DVT is top notch because it allows you to combine different execution clients, consensus client, and validators clients for the setup. So as some of the use cases of DVT is that they use it in staking pools. So DVT can improve the trustworthiness of staking pools by spreading key management responsibilities across multiple validators, and this reduces the risk of malicious actions or downtime from individual operations. So what this simply means is that even when there is downtime, your setup will still be active um, and and able to perform its validator duty. So yeah, staking pools basically incorporates this technology into their setup. And also another use case is staking as a service. So that's where So in this case, DVT will enable institutions to decentralize key management, thereby improving the resilience of their staking operations. So it then allows multiple node operators to participate using different hardwares and software configuration. And that's really amazing. And the last use case on this slide is for solo stakers. So you can engage in a node custodial staking by distributing the validator's key shares across multiple nodes. So basically, anybody here can participate, can incorporate DVT into their setup, into their existing setup. So this eliminates the need for a single hardware device, improving security and decentralization. So basically that's just it. DVT. So I feel like the easiest way to understand this, if you know how multi-sig works, then that yeah, basically the same approach. So yeah, so this then brings us to the part where we need to talk about how it works. So yeah, basically
DVT works similarly to a multi-signature wallet where multiple participants share the responsibility of validating transactions. And so these are like some of the important things that happens when you have your DVT set up. So for the consensus protocol, one node in the cluster is selected as a block proposer, and this particular node shares the proposed block with the other nodes. So those other nodes then contribute their key shares to complete the signing, that's the signature. So once enough key shares are collected based on the minimum required threshold, then the block is proposed to the network. Then the other part is a multi-party computation. Each node only holds a portion of the validator's key. So through the multi-party computation, these key shares are combined in a secure manner, ensuring that no single node has access to the entire key. So basically, everyone has to like come together based on that threshold for any agreement to happen, to be enacted or implemented. And then there's the DKG ceremony, that's the distributed key generation. So this is basically the cryptographic process um, that generates and distributes key shares across multiple participating nodes. So making the responsibilities of holding the key more decentralized. So for this signing to happen for the overall setup, all the participating nodes has to be active, and that's when the handshake goes on. Like I think during the practical, this would make more sense. Right. So, but more into that eventually. So, and there's the thresholds signature scheme. Yeah, so I've just been talking about threshold. So it's just basically the minimum number of key shares that is required to validate or sign transaction. So and this threshold ensures that a significant number of nodes must agree before a transaction is. And then there's the Shamai secret sharing, and this is like the cryptographic algorithm that is used to securely distribute the key shares, making sure that unauthorized parties cannot access the entire key. And then we'll just look briefly on the overview for DVT setup. So basically, you need to like decide: do you want to set it alone, or you want to set it as a group, or you want to set it alone as a single operator? So as a group is better because then you now have like different node setup That's a multi-operator kind of setup. So that means you're not just having one particular node. So yeah, it's best for decentralized trust minimal validator setup, and this helps to share the responsibilities and risks across multiple participating nodes. But if you want to set it up as a single operator, so this one is simpler, but may require more trust because you just need to, trust that particular setup. So if the idea for you is that you want your system to be muted, then the multiple operator will be better because you don't need to trust one particular node for the operation. So it is not centralized. So this is suitable if you are an individual operator who prefer managing all the nodes yourself. Right? So and then there's the parts where you need to generate your keys. Um, you need to generate your ENR as well. So just it's basically like your Ethereum node record. So more into all of this when we get to the practical sessions. Just not to bore us with these terms. Then there's also the part where you then have to activate your DV. So once your cluster is ready and you've done the KG ceremony, your node is properly synced, you can move to the section or the part where you then activate your DV. That's your distributed validator. And this involves depositing your validator into the Ethereum staking system. Then you can also monitor your node. So you add your monitoring credentials. So this part, okay, some aspect of this is if you want, let's say you are running a DV also to for the OBOL team to track your node to know how it is performing. Yeah, because basically if you're running a DV OBOL DVT, there are also some opportunities for you where you can depending on the kind of DVT you're running, and also um, how your level of experience, like to what extent you're running it. So there are some credentials that are available. So I think for BDB there is the base technique credential. That's if you're able to run testnets DV, and there's the silver and a bunch of others. So these are like opportunities and also things to validate that you have experience running over DVT. So you also need to like set up some credentials, some monitoring credentials, to help the team to track the performance of your node. So this then helps them to track it and also give you that batch eventually if you requirement. And then talking about the benefits. So that slide and this basically the same thing, just that this part has both the benefits and challenges. So I'll just run through this. So the benefit is that it eliminates single point of failure. So if one node goes down, you have other nodes too that are still running. So that is helpful because your system will still do its validator's duty. It also enhances security through BLS digital signature. Um, so basically, you're still able to sign transactions, do all of those things right in a secure way. That's like the best way to explain this. So it also reinforces the network decentralization because you have like your different nodes in a cluster, not just one. So it is decentralized, not centralized. And it enables non-custodial staking for solo stakers. So basically, yeah, I think I explained this earlier. And then it improves trustworthiness of staking pools. Yeah, so basically, those staking pools that are using DVTs, even if one setup is down, you still have other validator um, perform these duties. And but what are some of the challenges that comes with this? One is the increased cost for hardware and software because you need to, since you're running different setups, you need to like get the hardware that will then run those softwares. So it increased cost for you. There's also the potential for latency in transaction. In a situation where you have like four nodes that have to sign a transaction before the actual processing happens, then you need to wait for all those nodes to sign. So the process during that time, there's this tendency that you have to wait, and that's where the latency happens. So, and then yeah, in a way, the setup might look more complex and also require some additional work, unlike the vanilla setup if you want to do your maintenance. So you just need to do some extra work on different node. So yes, the parts where it just requires extra effort from you. So and then it also requires coordination between multiple operators. So if for instance now we need to do the DKG ceremony and we have like four people, we have like five people in a cluster. So I would need to like collaborate with other people. For instance, we need to talk when we need to be online for the DKG ceremony to happen and stuff like that. So you just need to make sure you are collaborating with other people. So in a situation where one person is maybe in a meeting or busy or something, you would then have to have those kind of issues to deal with. So yeah, all of these are some things that there has to be be considered while you are setting up your DVT. So that's basically about DVT. And honestly, if you want to understand more about this, I would suggest you check the OBO. Just go online and just search OBO doc. You you have a lot of. I'm going to share the link on the group. Have more information on how these things work, and there are some videos. There are some videos too during the process of setting it up, so you will also gain better understanding on how it works. So yeah, I'm dropping this now. Okay, what do we need for the practical session so we can? Okay, so Jeremiah, basically the same way you set up your consensus client and execution client, you need it. Then if you then want to use your DVT, so let me get the link for OBO. So this quick start, so if you want to run basically from this quick start, from here you have more information on how you can set it up, and they're very easy. Follow the tutorial or the links there. So yeah, so let's just go to the other part where we talk about staking. Hope you can see my screen, this slide.
Yeah.
Okay, good. So staking is basically giving. Normally when you stake, it's like you're putting something at stake, right? So you're locking setting that thing, you're giving it out. So it's like taking a loan. you need collateral or something. So yeah, basically somewhat similar. So Ethereum staking basically allows anyone to lock in their ETH to become a validator on the Ethereum blockchain. So it helps to secure the network, and in return you earn reward. You also contribute to the network security and governance. And so yeah, after the merge, all of this, we now have. I think we've talked around this, right? From the first speaker, he clarified on that. So yeah, after the merge, then Ethereum switched to proof of stake, and that's where you now start staking. That's just it. So yeah, so what's Ethereum staking? So it involves depositing 32 ETH into a smart contract to become a validator. That's just it. So, and validators are responsible for authenticating transactions, proposing new blocks, and maintaining the network security. So when you stake your ETH, you help to govern Ethereum as the blockchain, as a network, and you earn reward for your contribution. So validators, they validate transactions, confirm transactions, and ensure legitimacy of transactions. They propose block. So when you get selected, when your validator gets selected, so you have the opportunity to add new block to blockchain. And through active participation, your validator helps protect the network from attack and ensure its integrity. So how does it actually work? So yeah, so this basically is a vanilla setup. It's like the normal way to validate your transaction. So it's the normal way to like participate in staking. So that's why you need, because you're not staking through a staking pool, or through a third party. You're doing it directly. So you need 32 ETH. So you just need to deposit, and then you now start performing your validator's duty. So you propose block, you vote on blocks, you also participate in committees that helps to keep the network synchronized. So sync committees, just like let's say your validator can just be chosen to help sync, because okay, if for instance there are new nodes that wants to come into the network, your validator can make it very easy for them to sync with the existing chains, existing um, data already. So the sync committee are like the node that participates in all of this.
Okay, so yeah, basically now let's talk about the some of the terminologies or some of the things around validators or around staking. So validator key, while we talked about the DVT, so we're just talking about validator key, validator key. Um, so yeah, so for the validator key, there's the public and private key pairs that is used for authentication, and performing on-chain activities like signing transactions and the like. So these are basically cryptographic keys, and they are essential for securing validators operation. So if you're running a validator node, you need this, you need a validator key. So if you're setting up your validators client, you also, that's where you start interacting. That's where you need to deposit and also do other setups too. So yeah, that's where the validator key comes in handy. And then there's the epoch. So this is basically like time interval, and it's approximately, let's say, 6.4 minutes, during which transactions are validated. So um so validators participate in committee for block voting during this period. So each epoch contains like 32 time slots, and that's where validators participate in. So it's more like they now vote on the block, right? And this happens. um so each lasting so the time interval lasts around 6.4 minutes. And then there's the consensus mechanism. That's the proof of stake, basically. So this is less energy intensive, unlike the proof of work. So you're just staking to secure the network. You're not mining, you're not solving any puzzle, you're not running any computation like that. So okay, so what are the different ways to stake? We have the home staking. We have the staking as a service. That's through third party services. Um, there's also the pool staking. So
Okay, I'm really sorry about that. My network has just been acting up. All right, so I'll just continue. So, ways to different ways to stake. There's a home staking. That's where you're doing it yourself. You're staking the complete 32E. You're rich. You have the money, so you earn the full reward. You're not splitting it. There's no smart contract that says certain percentage will come to you and others go to other people. So yeah, there's also the staking as a service. That's when you're using third-party services to manage your validator node. So this also requires a little it, no technical knowledge. Typically involves a service fee. So you're just using other services to do it. And then there's the staking pool. So that's where you can then maybe use 1.5 E, 2.5 or 2.4 E. You can use um, just you're not using just something lesser, right? And there are protocols that helps you achieve this. So but then the reward, you're not getting the full reward as someone who is running the complete 32, the vanilla setup. So so the reward will be shared, and this is more like the easiest way and requires very less or little or no technical skill. Yeah, so it's just stick through the poll, and yeah, that's it. So how to stake Ethereum? So you decide, do you want to stake alone? Do you want to use a service, or do you want to use other services too that involves pulling resources together? So once you have that, then you decide. So if you're going for home staking, that's where you now prepare your nodes, install the clients you need to run the software. So if it's through a service or a pool, you just decide on the one you want to do based on their reputation and also the reward, the benefits, and what you stand to gain basically. So then you then generate your validator key. So you create your validator key either independently or through your choosing service provider. Deposit your ETH to activate your validator, participate in the staking pool. So this is more like an overview of how you can stake on Ethereum. And the reason to stake, so financial reward, you earn reward, It's more like a way to earn passively, and it's sustainable. You're not contributing to global warming. You don't need higher amount of energy, but maybe you're contributing to global warming, but maybe in a very less or minimal way. So basically, you're supporting eco-friendly consensus because you just need little amount of energy to power your device and your hardware, and you're good to go. So there's also your support for the network. You're ensuring that it is decentralized, it is secure and robust. So basically, that's to an extent a reasonable reason why you should stake your Ethereum. And then, what are the risks that comes with staking Ethereum? So there's this thing called slashing and penalty. When you try to compromise the network or do something malicious, or maybe you don't perform your duty the way you're supposed because your node is down, even if you consciously did it or you consciously did it or it just happened, the rule is the rule, you get slashed or you pay fine. Yeah, but basically that's just it. Yeah, just some things that just happens to your staked it when you try to act maliciously or neglect your duty as a validator. And then there's the third party vulnerability. That's when you're staking through a third party service. There's this tendency that your, for instance, Bybit, now we heard what happened, the amount of $1 billion um, that was hacked. So even though they are using multi-sig, but for some reason the the system still became vulnerable. So yeah, things can happen, life can happen, and yeah, so there's this tendency that you get hacked. Yeah, and there's also the system failure part. So the security of your investment depends on the reliability of those third party service. And if you're running it on your own, it also depends on the reliability of your device, your hardware, and yourself, like how you tend to protect your mnemonics or your keys, your validator keys. And then there's the market volatility, where the value of ETH is fluctuating. Right now, we are seeing what's happening in the crypto markets. A lot of people are shouting and crying. So some people that have their ETH stake, you can't remove it, and you can't actually withdraw it. Like, I'm just saying that you still need to be any reward, right? But the value is decreasing. So if you have to ETH, what it was a few months back is still the same value, right? But it's still the same amount, but the value is fluctuating. So there's that part too, where price drops significantly, and this then affects your staking investment. But it doesn't affect your amount because you're still earning the same amount of it and the likes. Yeah. So how validators earn reward? So there's a consensus reward from the consensus layer, and there's also reward from the execution layer. So they are just classified as consensus layer rewards and execution layer rewards. So the rewards from the new ETH insurance, that's like consensus layer reward. So validators are rewarded for following protocol rules and performing validators duty or validation duties like proposing and attesting to blocks. So these rewards are influenced by your uptime because you need to be on 247. They can send your node a message and it has to respond. Yeah, so you just need to be online 247 um and being able to perform your duty. So Validators who stay online, perform their duty efficiently, earn maximum reward, while penalties are incurred for failures. So basically, when you don't do your required duty, you get penalized, or when you try to compromise the network, you get penalized. You face the penalty, right? So then on the consensus, on the execution layer part, so there is a transaction fee that people usually pay for their transaction to be added to the block, and depending on how you want these things, how fast you want your transaction to be processed. So sometimes you might need to like increase your gas fee, right? So there's also that part too. So um, transaction fee and MEV reward. So these are coming from the execution layer, um, execution layer. Yeah, yeah, basically execution layer. So yeah, that's so from transaction fee you earn reward too. Then so the number of active validators affects reward distribution. So if, for instance, there are more validators, so that means your node receive like small reward per validator. So let's say if you're running a DVT, for instance, and you have for a particular cluster you have 20 people, so the reward that is coming from Ethereum from the network is still that same amount, right? But it will then be splitted across all the validators participating. So there's also that part too. So more validators also means smaller reward per validators, and validators choosing to propose block earns priority transaction fee. Yeah, basically just like I said, if me, for instance, I want my transaction to be processed really fast, I can increase the gas fee, right? Because once there's congestion, the price gets higher, and yeah, so it's more like those people are now doing guy. Basically, it's simple economics, right? So the higher the demand, the scarcer or the more value the product gets. So something of that sort. So yeah, basically that's just it. So what are the importance of validator diversity? So I talked about client diversity for OBO. So there's also this part too, validators diversity. In some you can also call it client diversity too. So but this helps to ensure decentralization and reduce client risk. So basically, so there's also this geographical region point of view where it is advised, like for all, let's say, looking at the continent now, if for instance all the nodes are just running in Africa, all the nodes in of Ethereum are just running in Africa, there's also this part where if everybody in Africa decides to like change anything on the network, you can actually do it. If you want to compromise, just have more of the validators agree on something, and yeah, it just gets added, right? So we can also try to like research about 51, is it 51% attack or something? Yeah, basically that would also like give you more understanding of how you can actually compromise the network. But to be honest, it's very difficult. I but that's just by the way. So if you have like different nodes set up from different continents, different part of the world, there's also that part too. But you're looking at it from a geographical point of view. So Africa, we are contributing, we are trying, and we are not there yet. But yeah, in terms of participation, we are pushing. We are, you know, NodeBridge Africa is in the front line of ensuring that these things are feasible from the African geographical point region. Some yeah, basically. So
And there's also the client diversity. That's where instead of running just get and prison, you're running other minority clients like others that like the Lighthouse, Aragon, other ones that has like low amount, small, like very limited number of people. It's not like it's kind of limited, but in the sense that very few people tends to use it. So just those clients too, you also need to, use all of those clients as well. Like the minority, they call them the minority clients. So yeah, but so far, I the client diversity on Ethereum has improved because they talked about a lot of things. Like the awareness became more obvious, and people started talking about this and how it would eventually be a problem if the clients are not properly diversified. So yeah. So from the geographical point of view, geographical distribution prevents regional outage or regulatory changes from affecting a large portion of validators, simultaneously. So if, for instance, and they decide that if US now decide to ban anything Ethereum or anything blockchain, they now said any AWS should destroy any of their servers running cloud or something. Yeah, that might look like it's not possible, but is there anything impossible for government to do? But that's just something to think about. So if there's this policy change or something that just happened around the regulatory frameworks in any country or any region, it can also affect how the the network perform if it is not geographically distributed. So that's something we are really keen and working, like seeing that these things happens, especially in the African region. So why client diversity is crucial is because running different clients implementation prevents a single software bug from affecting the entire network, and this reduces drastically the risk of sensors failure or network split. So it addresses censorship in the network. So instead of, because we are all saying distributed system, decentralized system, but in a way that can be centralized if care is not properly taken. So, but yeah, that's basically it. And then lastly, step-by-step guides on becoming an Ethereum validator, just like we've talked of, just like we've said before. Have your clients fully installed, your execution client, consensus client. So this is basically for a vanilla setup. Have your clients all installed and in sync. Then you generate the deposit address. So basically, there's this deposit CLI. Um, so you need to create your mnemonics and your impute your. So I think we were doing the practical session, so like we have like more understanding on how these things. When I did the other section, when we are installing the from our previous session, I showed us one diagram like that. So that part is basically what this deposit CLI part is talking about, and more into that eventually. Then, so once you have that, you've created your mnemonics, your key shares, your deposit data, then you can deposit. So you go to the launch pad and then follow all the instructions, the steps there, make your deposits, fund the address with your 32 ETH, deposit it into the smart contract, and boom, you have your setup complete. And then you start, performing your duties and then earning reward. So that's basically
everything you need to know about staking on the Ethereum network and also running a DVT. So I believe I wasn't too fast. So, but yeah, basically, if you have any questions or you need further clarifications on any of these things that I've talked about, you can ask your questions. But yeah, that's just it. So conclusively, Ethereum staking provides a valuable opportunity for anyone. It's permissionless. You, me, everyone to engage with the Ethereum blockchain, contribute to its security, decentralization, network robustness, and also earn rewards. So, running a validator plays a crucial role in maintaining the network integrity through proposing blocks, voting on block validity, and participating in other essential tasks. So, whether you're staking as a solo staker or through a third party service or in a pool where you need to pull funds together, all the people they pull funds together to stake, it's important to consider the risk involved. So you need to make sure you have your hardware properly set up, you to some extent have the technical requirements or have a better understanding. So for me, I feel like wherever you are investing your money into, you also need to like know how it works and operates. So that would also help you as well. So you need the technical knowledge or a better understanding around that. And by understanding these dynamics of Ethereum staking, you can make informed decisions that aligns with your goals, your investment, whether it's how you can maximize reward or simplify your participation in the network in a sustainable way. So that's basically it. Thank you very much for your time today, and looking forward um, to your questions, contributions, and yeah, that's it. Thanks, guys.
Yeah, thank you very much, boss. Any question? So if there any question, you can just ask in the comment section or the comment section in the group. Thank you very much, guys. See you next week. Please get prepared. Practical starts next week. Please get prepared. Thank you.